one of the reasons why there was so much interest in your Delta Opioid Receptor work was because last year's Nobel Prize for Medicine was granted in this area based on work done on T regulatory cells. The three recipients had done work on how the immune system responded to Tregs, and then also the role of the FOXP3 gene. And I wanted to throw that in your court once again to explain the relationship between your work on the Delta Opioid Receptor and the findings from the recipients of the Nobel Prize in Medicine last year.
Yeah, great question. We were excited about that because it essentially validates a lot of the work that we're proceeding with in terms of the targets like MDSCs and macrophages. So you may recall your immune system when you're born is called your innate immune system. That's your first line of defense, both when you're pregnant, i.e. when you have the placenta to create that immunosuppressive environment. And then the second line of defense is your adaptive immune system. And what the Nobel Prize was based on was that more advanced portion of your immune system, called your adaptive immune system, has these cell types, as you mentioned, called regulatory T cells. And they induce a sense of tolerance to potential normal tissue antigens. And the reason they do that is you don't want to have, for example, the importance in an autoimmune disease, a lot of times your immune system stops recognizing your normal tissue as being normal, as being self, and attacks it. The FOXP3 gene is activated in these regulatory T cells. They become highly immunosuppressive, and they induce this tolerance. And the reason that's important is if you can activate these regulatory T cells to be immunosuppressive, they can have great applications in chronic inflammatory disease, et cetera. So what's relevant to what we're doing with the Delta Opioid Receptor is twofold. Regulatory T cells have a gene that produce opioids. It's called PENK3. And the PENK gene, by producing an opioid, must have a role in immunosuppression. And in fact, it does. The Delta Opioid Receptor, when activated in regulatory T cells, will activate the FOXP3 gene and cause those cells to be immunosuppressive. When the Delta Opioid Receptor is activated in macrophages or in MDSCs, which is our target of interest, it will cause those cells to become immunosuppressive. So now you've demonstrated that the Delta Opioid Receptor in 3 different cell types that the body uses for anti-inflammation capacity or immunosuppressive capability is all linked together. So you have this, what we call convergence between your innate immune system, your adaptive immune system, and the ability to control immunosuppression if you want it, or inhibit immunosuppression if you want to. So Tregs, macrophages, and MDSCs are all very important in tumor biology because they create that immunologic sanctuary. We can intervene with a delta opioid antagonist. We can shut off all 3 of those cell types and remove that, what we call that immunosuppressive tone or phenotype in the microenvironment. And that's, for us, kind of validating work. Nobody's demonstrated this on MDSCs, macrophages, et cetera. And I think the linkage to the gene, the immunosuppressive gene, that was the basis for the Nobel Prize really underscores kind of the potential of the technology that we're focusing on.